Welcome back, everybody. Here goes factoring difference of two squares with Mr. Longo. So factoring difference of two squares, it's very similar to factoring. I'm going to show you the little pattern that's going to happen. So we don't have an x value, so theoretically what we're doing is we're thinking of two numbers that will multiply to a -4 but add to a 0. So in this case, we're going to have 2 and a -2, because that's going to multiply to a -4 but add to 0. So that's going to give us x plus 2 and x minus 2. Now, to use a little shortcut pattern, whenever you notice that you have two perfect squares, just like this previous example, because that's the only way you're going to be able to add up to 0, and it's a minus sign. It has to be minus. So what you do is you ask yourself what the square root of x squared is, and you're just going to say x, because x times x is x squared, and what is the square root of 9? You would say 3, but you're going to have a positive 3 and a -3, because that's the only way to multiply to a -9. Now again, like I said, it only works for the difference of two squares. It does not work in this case, so this is going to be prime. Okay, so the answer is prime. And if you don't believe me, and you want to say, no, I think it's x plus 5 times x plus 5, then I'm going to tell you to go FOIL that. And you're going to say x times x is x squared, and then x times 5 is 5x, and x times 5 again is 5x, and then 5 times 5 is 25, and you get x squared plus 10x plus 25. That obviously does not equal x squared plus 25. So again, it only works if it's the difference of two perfect squares. So your answer is prime. Okay? Going on to the next row. We get something a little bigger, but it's still going to be the same thing, because 4x squared is still a perfect square. So the square root of 4 is 2. And the square root of x squared is x, and the square root of 9 is 3. So you're going to have 2x plus 3 and 2x minus 3. So now that we've done quite a few examples, why don't you pause the video and try the next two? Give it a shot. And you should have came up with 5x plus 1 and 5x minus 1. Remember, 1 is still a perfect square because 1 times 1 is 1. And the last example, just like we've talked about before, whenever it is possible to factor out a GCF, you should do so. You could factor out a 2 from both of these, so you're left with x squared minus 100. X squared and 100 are both perfect squares, so you have 2 times x plus 10 and x minus 10. And again, if you're slick with a graphing calculator, you can use your graphing calculator to check to see if you've done those correctly. Let's move on. You thought you were done, but you got 3 more. Now these are a little bit trickier. So what I want you to do is pause the video and see if you can work your way through these 3 examples. And I am saying there is a trick to some of them. The one in the middle is actually straightforward and simple, but the 2 on the ends, I want to see if you can get those. So give it a shot. So the 9x squared minus 36. If you said 3x minus 6 and 3x plus 6, you're kind of right, but you're not done. Whenever you're factoring, you must factor completely, which is why I always tell you the first thing you should do is factor out a GCF when possible. And you would have an x squared minus 4 on the inside. So you should have 9 times x minus 2 and x plus 2. So what you might be wondering is, could you have just continued from the last one? Yes, you could. If you said that you had 3x minus 6 and 3x plus 6, you still have to look for GCFs, even if it's not the first step you do. So you could factor out a 3 from this leaving you with x minus 2. And you can factor out a 3 from the second one, leaving you with x plus 2. And your 3's on the outside can just be multiplied together and combine those to 9 times x minus 2 times x plus 2. So you get the exact same answer, but in order to keep things a little bit safer, you should always look for a GCF first. Next example, the square root of x to the 6th is x cubed, and the square root of 25 is 5. So you should have had x cubed plus 5 and x cubed minus 5. Again, any even power, it can be square rooted when we're working with variables. And finally, the last one. The square root of x to the 4th is x squared, so you should have x squared minus 4 and x squared plus 4. But hopefully you realize that x squared minus 4 is difference of two squares again. So just this x squared minus 4 could have been factored to x plus 2 and x minus 2. And of course you must keep the x squared plus 4. So that long thing right there on the bottom, that would have been your final answer. Okay, now we are done with this video on factoring by the difference of two squares. This is Longo and I'm out. See you, bye.